Everyone, this is part 2 of CBSE 2020-25 Mathematics Standard Paper Solving, and now we are going to continue with our session, right? So here comes the sixth question. We are related solved five questions, so now here's sixth question. Okay, let's start it. If HCF of 98 and 28 is equals to M, okay, if HCF of 98 and 28 equals to M, so M should be equals to 14. You say, sir, how? This how is very difficult, but it's very easy if you see. See, 98 can be 28 have the highest factor, that is 14, and 28 is also there, but 28 is not a factor of 98, but 14 is a factor of 98, because 14 5s are 70, and 70 plus 28 is equals to 7. So 14 into 7 is 98. So the highest common factor is 14. So M is equals to 14, right? And what happened here? Just a minute. Yeah, just a minute. This is hanging a little bit. No worries. So M is equals to 14. Oh, it gone. Wait. Yeah. M is equals to 14 and N. What is N? N is LCM of 98 and 28. So the lowest common multiple of the both, through which both gets multiplied. So 198 into 2, 196, 140, and yeah, 196. So n is equals to 196. You know how to calculate LCM and HCF. So their sum is equals to what it asked. It has n minus 7n. So n minus 7m, that is 7 into 14. So that's 96. That's 96. Sorry, 98. So the final answer is 98, right? So take it. And please, if you're saying how I calculated, then it's very easy. I think you know LCM and HCF. There is no think of it, right? Seventh question. Seventh question. Now we are going to seventh question. The tangents drawn at an extremist of the diameter of circle are always the tangents. Just a second. I'm going to show you through this, right? See, I'll be creating one over here so that you can see. Just a second. Let it put in the side. Okay, and just put it here. So see, the tangents drawn at the extreme end of the diameter. Uh, this, right? This of a circle. So circle is like this. Yeah. So now it's again tangents drawn at the extremities of the diameter of the circle. So diameter is this, like this, or just a second. Make it like this. Diameter is like this, right? So the what we are asked, tangents drawn. So if the tangents are drawn like this, even open that here. This and this, if these are the two tangents at the extremes, then they are parallel, right? Because they will never going to intersect each other. So answer is parallel. Now another question. In a triangle, in triangles, just a second. Yeah, in triangles, in triangles ABC and DEF, ABC and DEF. Yeah, oh sorry, A, B, C, and DEF, D, E, and F, right? Ignore that. B is equals to E, okay. F is equals to C, okay. And AB is equals to 3D. So AB is equals to 3D. That means AB upon DE. 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 is equals to 3, right? So see, here is one thing. If you can see, both are similar because we can apply triple double A condition. Two angles are equal, then by double A they are similar. Now we have to check whether it is congruent or not. So if it would have been congruent, then AB should have been equal to D, but AB upon DE is equals to 3. Hence it is not congruent, right? It is not congruent because if it would be at congruent, then the sides must have been equal. So answer is, so the correct answer is which similar, similar but not congruent. D. Okay. Next question. Roll it back and just make it huge. Okay. So next question is, if negative n minus n is dash dash dash. So basically see, minus 8 minus 1's power 8 is equals to 1, right? And we are asked about minus 1. So what we have to do, we can make equation something like this. Power n is equals to, here minus 1 power 8 is equals to 1. So if we will go over there, it will become minus 1, right? So if minus 1's power is coming minus 1, then power n must be some odd number because odd power always results in negative number, right? So the answer is odd number, any odd number, any odd number. C is the answer. Okay, let me circle it. C. Okay, now 10th question. Two polynomials are shown in the given figure. The number of distinct zeros of both the polynomial is. So we have to tell distinct polynomials, the number of distinct polynomials or distinct zeros that both the polynomial have. Distinct, what they mean by distinct? They mean that the different zeros, right? The different zeros, distinct, which are not common in both. So if you will see, this zero is common. Oh, sorry. This zero is common. This zero is also common. But, but, this zero, and but these are not zeros. If it is cutting the y-axis, then it is not zero, right? So this and this. So if you talk about distinct, what do you think will the answer? It will be 2 because this is the 0 and this is the 0, right? There are two zeros. And if they would have asked the number of zeros that the both polynomial have, then answer would have been 4 because two zeros of the first polynomial and two zeros of y polynomial. But they have asked distinct number of zeros. So if they had asked about distinct, then surely they are talking about distinct, which means not same. So it is 2, right? Next one. If the sum of first m terms of an AP is itne, then find its second term. Okay, so the equation becomes like this. Just a second. Yeah. Equation becomes like this. Do you know the formula of it? N by 2 2a plus bracket n minus 1 d is the sum, right? So they have said it is equals to 2m square 2m square plus 3m, right? It is equal to this sum of first m terms. So here you can replace it by m. Here you can replace it by m. No worries. Then it's second term. They're asking for the second term, right? So simply we can do one thing. We can do one thing. We can send the 2 over there, transpose the 2, so that the equation becomes 2am plus this one becomes m minus 1 d, right? Is equals to 2m square and 2 went over there. So it's 4m square plus 9m square. not square. Why square will come over there, right? So what we send, we set 2 over there, right? So it will become 6m simply. Okay. Now the part. Now the part comes. Now the part comes. Now the part comes. Uh, 2am plus m square, not m square directly, m into md minus d, right? M square, m square, why m square? Md, sorry, md minus d is equals to 4, this, right? Same thing. So it will become 2am plus m square d minus md, right? Equals to 4 m square plus 6m. Now if you can see, we have 2am, we have m square d and minus md, right? Now what we can do is, what we can do, think of it a little bit. It's a very good question, I think. Very good question. Very good. Think about it. What we can do over here. So I'm giving you that question as a homework because it is very good question. However, I have a doubt in that because answer cannot come as a numeric. It is very difficult. So I'm going to check it first that whether it had an answer or it was a misprint question inside my PDF. So then I'm going to tell you. So you don't do don't take it as a homework, but try to research about it, right? And I will be discussing in the next part. So move on to question number 13. A card is selected at random from a deck of 52 playing cards. The probability of it being a red face is. Now see, it is asking about red face. So red face card. Now what is face card? Do you know what is face card? There is one face card inside every 13 group. So if there is a group of 13 cards, then it may contain one face card. And there is 26 red cards. So if there are 26 red cards, then there will be two face cards, right? There will be two face cards. So the probability is, oh, it is asking for face card. Oh, okay. So if you know that there are actually three face cards or four face cards, you know about that? Do you know about that? King, what goes? We have king. Wait. We have king, queen, and one more is there, right? So we have three face cards. So total red face cards must be 6 upon 26 because there are 26 red cards and 3 in group of 13. So the answer that comes is 3 upon 13. 13, right? We cut both sides. So answer is 3 upon 13. Oh, I marked it wrong. Just a minute. Right. This. Okay. Done. Did you understand it? See, there are 52 cards. Half of them are red. So total red cards 26. Now face cards are those cards which contain the faces or symbols of monarchy. So there are three face cards in group of 13. So if we have 26 cards, then we must have 6 face cards, right? And if we divide both the numbers, numerator and denominator by 2, we'll get 3 upon 13. Okay, this. Which of the following is a rational number? Which of the following is a rational number between root 3 and root 5? See, we have to calculate a rational number between both of them. Okay, now root 3 is basically 1.7, I think, 1.7 something. And root 5. Let's evaluate root 5. Let's evaluate root 5. So 1.00 and then it will come over there. So it's somewhat like 2.2. Okay, 2.2 something like this. So we have to calculate a number in between. So if it is 2.2, then this will not come. This will also not come. Pi will also not come. It is 3.14. It is 2.3. So these two options cancels out. Now these two options remains 1 upon 4 and 1 upon 8. 1 upon 4 rejects out because it is not coming it is before 1.7. So the R option is 1.85714. Okay. So I think that's much is enough for this session. We have covered 15 minutes, right? And we had done a lot of questions. So I think we had covered one, two, three, four, five, six, 7 questions we have done today. So that's it for today's session. We'll be going to continue the rest one in the next part. Till then, thank you. Bye bye.